Hello out there, welcome to this tutorial on geometry of a straight line. This is part one of this tutorial. We are going to be looking at distance between 2 points. So we consider the diagram below. This is the Cartesian plane with x-axis, y-axis, and this is a straight line. This straight line will have a point A, x1, y1, and B, x2, y2, where the intersection of the x-axis and y-axis is called the origin. So if you take AB to be the distance between A and B, or the length of the line AB from this finite point, then we are going to have it as square root of x2 minus x1 all squared plus y2 minus y1 all squared. This is the formula we are going to be using in this tutorial to calculate either the length of a line or distance between 2 points. So we have the first problem. Problem 1. Find the distance between the following pairs of points. So we pick the first problem, which is 2, 4 and -1, 0. So we still remember our formula for calculating distance between 2 points. So what we'll do here now is to name the points. So we have, this is x1, y1, this is x2, y2. So calculating the distance, we call it L. That's going to be square root of x2 is -1 and the x1 is 2, so -1 minus 2 all squared, then plus y2 is 0, so we have 0, and y1 is 4, so we have 0 minus 4 all squared. This giving us -1 minus 2 gives -3 squared plus -4 squared. This is giving us square root of 9 plus 16, since -3 squared is 9 and -4 squared is 16. 9 plus 15 gives 25, so square root of 25 gives 5 units. So the distance between the point 2, 4 and -1, 0 is 5 units. Then we go to B. For B, we have 3, -5 and 4, 5. Again, we name the point. This is x1, y1. This is x2, y2. So the distance between the 2 points now is going to be square root of x2, which is 4, minus x1, that is -3 squared, then plus y2 is 5, y1 is -5. So -5 minus 5 will give us +5 squared. I hope you understand that. This is negative y1 and -5. y1 is -5. Negative gives positive, so we have +5 then squared. Simplifying this, we have square root of 4 minus 3 gives 1 squared. So 5 plus 5 gives 10, so we have it as +10 squared. And here is going to give us 1 plus 100, giving us square root of 101 units. This cannot be simplified further, and we are leaving our answer in short form. So that's all for problem 1b. We then go to C. For C, we have -4, 1 and -2, -3. Naming the point again, this is x1, y1, x2, y2. For your information, if you like, you can name this one x2, y2 and name this one x1, y1. It does not matter. The same thing, it could be x1 minus x2 and y1 minus y2. It doesn't matter. So substituting into our formula, we have square root of x2, which is -2 minus x1, that is minus minus 4, which will give us plus 4 all squared. Then plus y2 is negative 3 minus y1, and our y1 is 1, so minus 1 all squared. This is simplifying this. Negative 2 plus 4 gives 2 squared. Negative 3 minus 1 gives negative 4, so we have it as plus negative 4 squared. This is giving us 4 plus 16. 4 plus 16 will give us 20. We have root 20. This root 20 can be simplified further since it has a factor that is a perfect square. That's 4 times 5. So square root of 4 there will give us 2. Then the square root of 5 will just give us root 5. Then 2 root 5 units is the distance between the points negative 1, 1 and negative 2, negative 3. That's all for C. We then go for D. So for D, negative 1, negative 6 and 4, 1. So we name the points again, x1, y1 and x2, y2. So the distance now, substituting into the formula, x2 is 4 minus x1, that is minus minus 1 gives plus 1 all squared. Then plus y2, which is 1, minus minus 6 gives plus 6 all squared. This is giving us square root of 5 squared plus 7 squared. 5 squared gives 25 plus 49. So 25 plus 49 gives 74 units. Since this cannot be further simplified. So that's all for D, and this is the end of solution to problem 1. We then go to problem 2. Problem 2, in the Cartesian graph, calculate the length of the line between the two intercepts. The length of the line between these two intercepts. This is intercept on x-axis. This is intercept on y-axis. So we have to calculate the distance from here to this point. So in our solution, remember we are still going to use this formula. So the first thing then to do is to get our points. So on the x-axis, y is always 0, and here this is x is 6. So our first point is going to be 6, 0. This is x, y. And the second point on the y-axis, x is also always 0. So at that point, we are going to have 0, 3 as the second point. We still name the point x1, y1, x2, y2. So that what we'll do is to substitute into our formula again, L, square root of x2. x2 is 0 minus x1, that's going to give us minus 6 all squared. Then plus y2 is 3, then minus y1, our y1 is 0, that's minus 0 squared, giving us square root of negative 6 squared plus 3 squared. Negative 6 squared is 36 plus 9, since 3 squared is 9. And 36 plus 9 gives square root of 45. We can simplify this further. 45 is 9 times 5, and square root of 9 will give us a 3, then square root of 5 units. So we have our distance from this point to this point, that is between the two intercepts, to be 3 root 5 units. And that's all for problem 2, and this is the end of this tutorial on distance between 2 points. Check the description section of this video on our YouTube channel to get the link to the second part of this tutorial. Until we come your way again, Goodbye.